welcome to video number 18. We're going to be talking about the relationships between something like force and torque and how angular kinematics is similar to linear kinematics in that way. So let's get started off right with that. All right. So force is equal to mass times acceleration. We know that, except for in rotational kinematics, the equivalent for force is torque. Then the equivalent for mass would be moment of inertia represented by I, and then acceleration would be angular acceleration. So here we have torque equals moment of inertia times angular acceleration. Torque is very similar to force, so it's like how much torque is exerted on an object. Positive torque is counterclockwise, negative torque is clockwise. So let's try to incorporate torque into the problem, the same one we had before. All right, we have two discs. We have one disc rotating, one at standstill. Then when the other one is dropped onto it, they come to a new final velocity of angular velocity final. That's what we're going to call it. And all of this happens in a time period of delta t. So what we are trying to find is the magnitude of the average torque. So we want to find torque. And we find that through moment of inertia times angular acceleration. Moment of inertia is given as mr squared over 2. Acceleration, however, it's not given, but we are given the initial angular velocity, and we are also given the time period, delta t. And just how velocity over time is acceleration, angular velocity over time is angular acceleration. So now we can incorporate it. We know that the angular velocity would be the angular velocity final. However, remember we need to incorporate t. So all of this is times delta t. And this is equal to torque.